This conference will now be recorded.
Okay, so last class we discussed about, finally we discussed about this interface concept, right? And after that, before that, we discussed about scenarios in Hadoop installation, and we have, I have given some scenarios, some 4 scenarios, and which is having a common solution, which you know already. So just we need to observe the namespace IDs of the respective files. I mean, whether it is a name node or data node, and even the cluster ID is also important. Okay, and after that, we discussed about this interface concept. We will discuss this. I mean, just I will recall this interface concept with a small example, and then we can go further. Okay, so let me explain you. I mean, let me recall this interface concept. So first of all, if you want to define an interface, so we require a keyword called as interface followed by some interface name, right? Maybe some first. And within an interface, right? We are having only abstract methods. We don't have the concept of concrete methods. So just try to define some abstract methods. Nothing but abstract void m1, and I am defining one more abstract method, abstract void m2. So like this, you can define any number of methods based upon your requirement. So now, after creating some members, generally if you observe this normal classes, so just we are creating a method and we are trying, sorry, just we're creating an object and we are trying to access the members of a class, right? So let me create an object for this an interface. So that is first some t is equal to new first. So whenever I'm creating like this, so immediately we're going to get compile time error. First is an abstract class, can't be instantiated. Can't be instantiated means we're unable to create an object. Okay. So case 2. So creating an object for an interface is not possible. But what about reference variable? Can we create a reference variable for an interface or not? Okay. So that is first t1, nothing but just we're creating a reference variable, that's it. But now by using this reference variable, if you want to access this members of an interface, I mean like this t1.m1, here whenever if you're accessing any members of an interface like t1.m1, immediately here we are getting some compile time error. T1 might not have been initialized. T1 might not have been initialized. This is the one more compile time error which are getting. Okay. After that, so now if you want to get a reference variable for an interface, so here we require one more concept called as an implementation class, which we discussed already. Okay. So first of all, if you want to create an implementation class, so we require a keyword called as an implements. Okay, followed by some interface name. Means like this. So assume that my implementation class name is class B, followed by implements keyword. Okay, class B implements. So for which interface I want to create an implementation class here? Nothing but interface first, like this. Okay. So now within this class B, so within this class B, we need to provide the necessary implementation of abstract methods. So within an interface, you're having some 100 abstract methods means for each and every method, for each and every abstract method, respect to implementation, we need to provide in class B. Okay. While providing the implementation, so we need to include a one more keyword called as public. So why we're including the public, I will discuss in practical. At this point of time, no need to worry. So like this, public void m1. public void m1, public void m2, so like this, public void m3, so like this. So now let me create a reference variable for an interface here. So case 3, so that is first t2 is equal to new b. Here if you observe, right, so we are not creating an object for an interface, we are creating an object for implementation class. So after new keyword, right, whatever the class name we are appointing for that respective class only, we are creating an object. Okay, here we are not creating an object for an interface, I mean first. So if you observe here first t2, now if you observe that t2 is a reference variable of which interface? Nothing but first. Okay, t2 is t2 is a reference variable of interface first, and we are creating an object for implementation class. So now by using t2, by using t2, we are able to access only interface members, means t2 dot m1 and t2 dot m2 and case 4. So just I'm creating a reference variable and as well as object for implementation class. So now by using b, we are able to access both interface members and as well as class b members. Okay, means b dot m1, b dot m2, b dot m3, like this. Okay, so this is a way for accessing the implementation class and as well as interface members here. So generally we are going with case 4 only, whether if you're going with abstract classes or interfaces, so we're going with always case 4 when compared to case 3. Okay, so that's all for interfaces. So these things we have done, I mean basic programming skills, identifying the core concepts here. So how to create a class, how to create an object, okay, how to access the members of a class, how to pass some parameters to the methods, how to catch the respective return tag and abstract classes, and lastly interfaces. So these concepts, I mean concepts means just what is what we have done, that's it. Okay, so we did not go for in depth of these concepts, I mean practically just we're discussing about I mean just how to create a simple class, creating an object and accessing the members. These are the basic things, but we did not discuss about what is exactly a class, what is an exact object. Okay, what is the difference between interface and abstract. These things we will discuss later. Okay, fine. So till now fine, all of you, I hope. Okay, fine.
This conference will now be recorded.
Okay. So if you observe the last couple of classes, right, we discussed about what is the reason to go for HDFS. And within the HDFS, we have discussed three concepts. One is block size, replication factor, and metadata, right? So let us recall these concepts, HDFS, and then we can go for, some more concepts within the HDFS. Okay, so HDFS, Hadoop distributed file system. So now within this HDFS, we're having three concepts. One is block size. Second one is replication factor. And third one is metadata. In HDFS point of view, it is a namespace. Okay, so now if you're going with a block size, so the default block size in Hadoop is, what is the default block size here? 64 MB. So that is Hadoop 1.x. Hadoop 1.x, it is 64 MB. But if you go with Hadoop 2.x, what is the default block size here? 128 MB. Okay, now we're having a file with the size as a maybe some 54 MB. If you are going with the default block size as 64 MB, okay, how many blocks is required here, all of you? How many blocks it is required? Only one block. So now if you are having F2 with 120 MB, so how many blocks were required? How many blocks? Two blocks, right? B1 and B2. So like this. So depends upon your file, whatever the memory of your file or whatever the MBs it is having, and based upon your block size, whatever the block size in which you have configured, based upon that, so Hadoop will automatically splits the given file into number of blocks, depends upon your block size. Okay, that is a very important point here. Hadoop automatically splits the given file into n number of blocks. Hadoop automatically splits the given file into n number of blocks, depends upon your block size. Depends upon your block size. Okay. And second thing, replication factor. Replication factor. So the default replication factor, the default replication factor in Hadoop is 3. The default replication factor in Hadoop is 3. Minimum is 1, maximum is 512. Okay. So here most of you having some confusion on replication, so I will explain you clearly. Okay, so replication means duplication of blocks. Okay, duplication of blocks. So note, Hadoop automatically replicates the data. Hadoop automatically replicates the data. So I'll explain this replication factor. Give me some time. And last one is metadata. So that thing that is nothing but data about the data. Where exactly data is residing. That nothing but metadata. In a Hadoop point of view, it is calling as a namespace. So Hadoop automatically maintains the metadata. Hadoop automatically maintains the metadata here. Okay. So now if you observe this replication, let me explain you here. So assume that this is a cluster which is having some machines, maybe some N1, N2, and N3. So like this. So assume that we're having a file with 120 MB as a block, I mean 120 MB as a size. So if you're going with 64 MB, so it required two blocks, B1 and B2, right? If you are assuming block size as a 64 MB. So now here this B1 block, okay, I'm storing within this system. I mean, let's assume the system is maybe some N1, N2, and N3. So now here I'm storing B1 here, maybe some B2. Okay, for some unknown regions, so if the system is down, okay, if the system is down, okay, so what Hadoop is promising, Hadoop framework is promising is at any point of time there is no loss of data, okay, or whenever the client is accessing my cluster, Hadoop cluster, so I want to give the data in n number of ways. So n number of ways means within a cluster, if you're having some 100 machines or 10 machines, if some couple of machines or couple of whatever the VMs or whether it is a machines, if it is down also, I need to show the data to the client, I mean end user. That is what Hadoop is promising. Okay, so for this they are following the concept called as a replication factor. Means, so here if you observe, replication factor is 3. Okay, already we're having B1 block, how many times here? Only one time. Okay, so now it will replicate two more blocks, total number of blocks is 3. Okay, whatever the block we're having, it will replicate two more blocks, because what is replication factor here? By default it is 3. I mean total number of blocks, it has to be 3. Already we are having block 1, so B1 it is going to replicate two more blocks here. So here one more B1 and here one more B1, and same as B2 as well. B2, B2. So if you observe, total number of B1 blocks within this cluster is 3. Then what is exactly replication factor? Okay, so maximum in real time they will take some 5 to 6, less than 10, so they will take as a replication factor. Okay, so for very critical, okay, very critical scenarios, if this three system is down means definitely at the, I mean, we are losing the data. If a client is accessing a cluster means definitely is get some 404 error found, or something, some status is not found, like this they're going to get some I mean error is going to be displayed to the client. So that is the reason they will replicate, I mean replication factor they will improve as maybe some 4 5 or less than 10 value, they will maximum they will take it as 8 9 like that. Okay, less than 10 only, but maximum is how much? 512. Okay, single b1 block can be replicated to 512 times, I mean 511 times, because total number is 512, right? So these things which we discussed already, just I have recall this one. So now if you define what is exactly Hadoop, what is Hadoop here, which we defined already. Hadoop is an open source Java based programming framework. Java based programming framework that supports the processing of large data sets in a distributed environment. Hadoop is an open source Java-based programming framework that supports the processing of large data sets in a distributed environment. I mean, clustering, clustering architecture. Simply, you can say that distributed means clustering architecture. Okay, this is about what is exactly Hadoop. Anybody is having doubts? One question here: if I'm using 1.x Hadoop on my file size 80 MB, then first will be one block 64 MB, and in the next block 16 MB. So next time, will it continue from 17th MB of last block, or will take a new block? So here, if you're having it two blocks, just assume that this is 64 MB, right? 64 MB is done. There is one more 64 MB. Okay, so if assume that our file size is maybe some 80 MB, so here 64 is already done, right? 64 MB. So 80 minus 64, how much? I think 16, right? 16. So now this 16, it will fill up into this 64 MB block, right? So 64 minus 16, it is having some value, nothing but it is having some free space, right? So if some file is coming, so for suppose maybe some 20 MB or 30 MB is there, so that file, it will be fit into this respective block. Or we can say that whatever the next file it is coming, so it will be utilized, whatever the size it is having. So because whenever if you're inserting some files in the Hadoop, I mean HDFS, whenever if you're storing some data within the HDFS, so definitely whatever the size or whatever the block size it is remaining out of the block, I mean 64 MB is my block size, right? Here I utilized some 10 MB, just assume. Remaining 54 MB it will be utilized for another file. So there is no wastage of memory here. Got it? Any doubts? Okay, fine. So now listen this concept clearly. So now if you observe Hadoop, this is Hadoop, right? So within the Hadoop, we're having one is HDFS, one is, and one more thing is map reduce, right? HDFS plus map reduce. Map reduce. So now if you observe these process names, right? Process names means Hadoop process names or Hadoop daemons, right? Process names, nothing but Hadoop daemons, right? So if you observe the HDFS point of view, if you observe the HDFS point of view. So first of all, if you observe the process names, what are the process names we're having? So nothing but name node, data node, secondary name node, uh, job tracker, and task tracker. This is Hadoop 1.x, right? But if you observe here, we have installed the Hadoop 2.x. So that is nothing but resource manager and node manager, right? Resource manager and node manager. Okay. So now out of this, I mean, what are the process names which I have mentioned, right? So out of these process names, so which process names comes under HDFS and which process names related to MapReduce? So now if you observe the HDFS point of view, so that is name node, data node, and secondary name node. Okay, name node, data node, and secondary name node. So these process names which comes under uh, which comes under HDFS. Okay, so now if you observe remaining process names, what are the process names you're having, which comes under MapReduce? So job, job, job tracker. So that is nothing but resource manager, task tracker. That is node manager. Okay, so these two process names which comes under MapReduce. Okay, so now I mean you have cleared in this respective point, right? So nothing but here what are the total Hadoop daemons or Hadoop process names. So which comes under two parts. One is HDFS and one more thing is MapReduce. And these process names comes under HDFS and these process names related to MapReduce here. And here one more thing is RPC port. Okay. So here RPC means remote procedure call. RPC means remote procedure call. What is exactly this RPC? We will discuss. So RPC port for this name node is 8020. We don't have RPC for data node and secondary name node here. And here we're having a RPC for job tracker as well. That is 8021. 8021. And here we're having a one more port. So that is HTTP port. HTTP port. So that is 50070 HTTP port for name node. And for data node, what is HTTP port here? Data node 50075, and for secondary name node 50090, and for job tracker 50030, and for task tracker 50060. So we are saying that, so this whatever the daemons, I mean whenever if you're starting the Hadoop, start hyphen all dot sh, okay, these Hadoop process names or Hadoop daemons, these these things they are running at background. I mean Hadoop daemons are running at background, okay. But if you want to know what is exactly going on, or if you want to see as a some UI part, okay, then we can go with these respective ports. So HTTP means hypertext transfer protocol, means by using a web browser, any what are the web browsers we're having, by using the web browser, so we can easily know what is going on inside of name node, data node. For suppose if you have inserted some data inside of HDFS, so let us assume you have copied some first.txt. So we are having some HDFS comments, we'll discuss later. But let us assume you have copied something, maybe some first.txt from HDFS. So just I want to see, okay, where it is exactly stored. What is the default location? For suppose if you are not mentioned any location, what is the default location? Okay, so how it is storing? What is the architecture? I mean, architecture means what is the what we call what is the directory path. So these all these things we can see if you go with UI path. If you're going with UI alone. So I think I have seen some Apache UI, right? So Apache UI I have seen, I think so. So by using, if you observe at the time, I mean whenever I'm showing, so I have typed some port as a 50070, which is a port for Hadoop. Okay, so these are the predefined ports for each and every process names. What are the process names we're having? So now what exactly name node is doing? Okay, storing the metadata. Okay, storing the metadata, nothing but namespace. What is exactly namespace? We'll discuss later. Okay, store in the metadata. How it is stored in the metadata? Okay, so these points we'll discuss in detail later. So let us just go with a small, small meaningful way. I mean, small words just for understanding what is name. And if anybody asks me, is just to store in the metadata. So can you explain in detail means? Then we can go for further. Okay. So data node. Now what about data node here? Storing the actual storing the actual data. So actual data means blocks. So if you observe my previous screenshot, right? So I just have divide a given file into n number of blocks. That blocks it is storing in some machines n1, n2. Okay, that is nothing but what is exactly data node in Hadoop point of view. Generally, we're calling as a machines n1, n2, n3, n4, right? Machine, one machine is nothing but a data node in Hadoop point of view. Hadoop terminology. Within your Hadoop terminology, what is a data node means machine. Okay, that is nothing but which it is going to actual data. So even though Hadoop is dividing the given file into n number of blocks based upon the block size. So these blocks, where it is exactly storing here, nothing but a machines. That machine is nothing but what is exactly data node. That is nothing but a storing the actual data. And means actual data means blocks. So where it is exactly storing here in Hadoop point of view, it is nothing but a data node. Okay. So now if you observe the secondary name node, so this is somewhat tricky. We will explain in detail later. Backup of name node backup of name node metadata, but not for process. Okay, backup of name node metadata, but not for process backup. So this is tricky here. Process backup. Okay, so this point I will explain it clearly later. But at this point, just remember as so whatever the metadata in which you are having in name node, same copy it is going to maintain in secondary name node, but not for process backup. We will discuss later. Just at this point of time, just remember as just it is going to store metadata of name node in secondary name node as well. Okay. So now if you observe the job tracker, observe the job tracker. Okay, assigning job tasks to task tracker or node manager. Assigning job tasks to task tracker or node manager. Okay, and finally task tracker here. Executing the job tasks given by job tracker or resource manager. Okay, and sends a response back to resource manager because we're going with 2.x. Okay, executing the job tasks given by job tracker. So job tracker is going to assign some tasks here. Okay, and whatever the task which is assigned by job tracker, so that task is executed by resource manager, and it will send the response back to the here node manager, right? Response back to the node manager. Okay, just you can assume it as a team lead and developer. So what is team lead is going to do? So based upon our what are the requirements which is having or what are the tasks which is having, couple of tasks which you have got from their superiors. So he will divide the respective tasks to the concerned persons. So for suppose if you're having a team lead with 3 developers, so it will divide that respective task into 3 developers point of view. So for suppose I'm having a 10 tasks, right? 10 tasks. So 2 tasks this one, 3 tasks this one, 2 tasks this one, like this. Remaining tasks, it depends upon the team lead whether he can do or not. But if you're going with emergencies, definitely they will not do. They will assign to some n number of developers. What are the developers they're having? Same way here, job tracker and task tracker. I mean, resource manager and node manager. So resource manager, so it will allocate some tasks to the task tracker, I mean node manager. So node manager will execute that couple of tasks which is given by job tracker, and it will send responses back to the job tracker. Okay, so is this fine? What are the things which are discussed here? So at this point, we know about RPC. RPC will discuss, and in detail of this process we will discuss later. But this is the simple meaning of each and every process names. So is it clear, all of you? What about remaining? Is it fine?
This conference will now be recorded.
So what is MapReduce is nothing but just it is a processing. It will process the data. Okay, so just here we're using the HDFS as a storage device. So and after storing some data inside of HDFS, so now you need to process that data and you need to display to the end user. So how it is going to happen is by using MapReduce. So if anybody knows Java, I mean if you're involved in web application development, okay, so we're having a UI which is maybe having two fields. Just assume that username and password. Once if we click on this save or once if we click on the submit button, what is going to happen? It is going to store these two values into maybe some MySQL database, and whatever the values it is stored just is going to retrieve and it is going to display. So if you observe clearly here, so just we are storing and just we are retrieving. Storing we are using as a MySQL. For retrieving, we need to use some frameworks. It depends upon your, I mean, it depends upon your architecture. Okay, you can go with either a Spring Boot or Spring MVC architecture. Okay, or maybe some Wicked framework, Apache Wicked framework, or maybe what we can say. What are the different frameworks? So many frameworks is there. Okay, but I'm not getting exactly. So generally, Java point of view, you're going with the Spring frameworks, right? So Spring framework we're using why we're using a Spring framework means nothing but it will define a well architecture, a clear architecture. What is exactly model? What is exactly view? What is exactly controller? So most of the frameworks, what are the frameworks we're having? So definitely they will follow MVC architecture, right? So now by using, we can say that, so by using Spring framework or by using the uh, by using this whatever the architecture which we are having exactly, by using the Spring framework, we are retrieving the data from MySQL and finally we are displaying to the end user, right? So here also same map is also. So here instead of MySQL, we are using storage device as a HDFS. So whatever the data which are stored, so we need to retrieve the data and we need to display to the client by using MapReduce. So not only MapReduce, even we can go with Hive also. Hive is also for processing. So it depends upon your completely requirement. What are the requirement we're having? Okay. What is the doubt? In Hadoop 2.x is the latest version in Hadoop. Is any of the Hadoop flavor like Hotnox has more than 120 MB block size? Hadoop flavor Hotnox. So no, maximum they will take 120 MB as a block size. Okay, because if you go with Hotnox Cloudera, they are the customized, right? For suppose I want to store huge amount of data, maybe some petabytes of data. So then I can ask this Hortonworks team, Hortonworks support team, or maybe some Cloudera. So just you can increase the block size to 256 because it is not a constant value. If you're going with the file systems, normal file systems, it is a default and it is a constant value. But if you're going with the Hadoop, either Apache Hadoop, Cloudera, or Hortonworks, what are the distributions we're having? Okay, you can change the value at based upon your requirements. Okay, I think Hortonworks and Cloudera also they are following with 128 MB as a block size. Default block size only they're going. But whenever I want to store huge amount of data, not only terabytes, if you're going with petabytes, zettabytes of data, currently I think most of the companies, what are the companies we're having? They don't have zettabytes, maybe some petabytes only. Okay. But if you're going with the product-based companies like Google, Yahoo, Facebook, Amazon, these companies definitely they're getting some zettabytes of data. They need to maintain huge Hadoop clusters, not a single cluster. They need to maintain huge Hadoop clusters. It may be some physical or it may be some data centers as well. Clear, Abdul? Is it fine? Any doubts till now? Is the doubt is clarified? Okay.
This conference will now be recorded.
So let me start the Hadoop first of all. Start -all.sh. Okay. Type JPS. Sorry. Okay. Every processes are running. So why my system is slow? So local host 50070. So this is the UI of Apache Hadoop. So if you observe these utils and here browse the file system. This is nothing but what is exactly HDFS. So click on browse the file system. So now if you store some data instead of HDFS, right? So generally if you give a slash and if you go with the go means, so it will display all the data, what are the data in which you have stored. Okay, so it will display the everything. Okay, block size here. If you observe the block size, and we discuss what is exactly block size and what is a replication, this thing also. So if anybody is updating a particular file within the HDFS, so it will provide the what is the last modified. I mean whether it is a whether it is a size or a group or a one or permissions. If you are changing some many permissions, this all these things it is be displayed here. Okay, so generally here we are going with a single node, so there is no change of this group one or on each and everything. But whenever if you're going with a cluster, because we are communicating within your network and it is a group of machines, right? So then it can be identified these all these things, permissions, these all these things, because what are the file in which I am working in cluster, the same file it can be worked by maybe some another developer as well, right? It depends. So that is the reason then it will be reflected here uh, in this directory. So just you need to go to utils and browse the file system, which comes under HDFS file system in Hadoop distributed file system. So once if you store some data, so it will display all these files, block size, each and everything. What is the name of your file, each and everything. So these things we'll discuss later. Okay. So this is 50070. So you can check it for the remaining ports as well. Maybe if, this is data node information. Okay. Most of the time we are accessing only name node because where the data is having is within this browser file system here. So we are keep on monitoring of only these things only. We are nowhere we are going for this reports which we're having. Sometimes we're going with this job tracker. Maximum times we're using job tracker port and name node port most of the times. Okay.